and how we can proceed further with comparison of data sets, how it can be done. So the utilities are multiple. It can be agriculture related, it can be coastal erosion related, and so let me share one screen before proceeding further. Um, yeah. So suppose if you is my screen visible?
Yes, sir. Yes,
Yeah.
visible.
Yeah. So you would have seen how the data 3D printing can be done from there, how the data can be extracted and how it can be used. Of course, there's other advantage also of the drone compared to satellite. The main reason being, one of the main reason being is over here, we will be able to fly during low tide, high tide, or maybe different crop periods based on what we want. It can be for a crop health, it can be for any other forest fire monitoring or any other applications. Here, this is a typical example of comparison how an ecotourism is being washed away by a typical case of heavy winds, rain, or an cyclone. So what happens is there's a typical example over here. And there are different years which you can compare seasons. You can activate the data sets of what you want. Accordingly, the data sets will get loaded onto it, and we'll be able to process it. Now, then accordingly, we'll be able to create the three-dimensional view and get the information and overlay onto the data sets. Now, let me, this is one example. It can be time-based comparison. So this is a typical example that we did in collaboration with the Karnataka Engineering Research Station and NITK Water Resource Department. And this is how a fixed wing aerial vehicle is being used. This was very old days, around 14 years back. Vishwas, is my that fixed wing aerial visible?
Yes, sir. Yes.
Yeah, yeah. So this is basically something like a passenger aircraft. The main advantage is endurance. It will fly for a longer duration. Now many improved versions, hybrid versions have come up. So this was built by students and staffs, wherein which balsa wood, thermocol, carbon fiber rods was used. And you can find a long range antenna for telemetry, and below there was a point and shoot camera. That time getting 10 megapixel was a very big image data set. Nowadays, all those things and all is available on your on your mobile. And a point and shoot camera was being connected, and a servo was used to trigger the photos. And this is how we were able to capture in the forest the encroachment land on the left hand side will be encroachment land and other features that that was used. All those data set was been studied. And this you have seen, you can see the Google Earth overlay on along with the drone image. So you can see a dam over here, and slowly the water storage what is there, and over here the water storage keeps becoming less, and from here the bed is dry, you'll be able to see the river bed. So this will also help them also identify what is the where suppose if they are intending to construct another small vented dam, where they can do, or how the dam is performing, or is it excessive drain of illegal pumps along this land. All those things can be verified. So this was our device which autonomous, which we showcased, we presented to the professor. So now Vishwas will start. Let me share the screen, the drone deploy and how it is getting processed. Vishwas?
Sir. I'll share the screen. Sir, is my screen visible? Can I get a
Yes,
feedback?
yes,
Yes,
yes.
yes.
Okay. So in the previous session we have put images for processing. We just uploaded, and rest of the things will be done by the software. So these are the same data. I have put it twice just to test it. So we can click on the data. So when you create new projects, new data you upload, so they'll be created like this. So you can keep on adding based on your requirements. And when we click on it, so this is the data that has been processed. So this is the processed data. So whereas this is the Google Maps data, so you can easily identify the difference in the resolution. For example, this resolution as well as the resolution over here. So if we fly with more accuracy with lower height, so we'll get actually much better accuracy. So when we fly at 80 meters or something, we'll get less than 2 centimeters the ground sampling distance. So each pixel of this image corresponds to particular distance. So those map quality, all those things can be kept over here. So we can export it into required formats, and also we can actually measure. So let's say I want to know the exact location of this. If I click, so it will show my lat long and its elevation. Right now, it is not georeferenced. That is why it is showing as negative. So when we put checker marks and do differential GPS and add those values, so the vertical elevation system will get proper referencing. Not only that, so we can also get the profiles, or like more like a cross section. For example, this roofs are so if I get a cross section of this region, so you can see I can hover over this graph. So it will show over here which point it corresponds to. So here some buildings roof will start, and this is the conical shape where the tiles are there, roof tiles. So this is where it the center, and it goes down. So we can actually modify this, and based on like what profile we want, all those things can be found out. So these regions are the where the trees are there. So again, there'll be roof, and again some road region. So it is very flat, and again there's some building will come. So again some vegetation, again one more building. So this is a like cross section. So along with this, we can also get digital elevation models. So this model tells based on color, height is given instead of RGB data. Also, we can actually create terrain only. So what terrain will do is it will like interpolate to remove the trees and see, just check how the ground is elevated. So they'll get a digital terrain model. So mainly this is very helpful in doing flood modeling or watershed delineation, all those things. And also we can go for the 3D model. So this is a 3D model. So it will take some time to load. So based on the survey, so to get proper 3D data, we need to take each image from like 5 angles, one from top and from each side, like at least four sides. So then only we'll get a proper 3D data along with the side walls and all. So right now, this is only an nadir images which is processed, but still we are able to get where the trees are, how high it is there, like all the details about this. So this is a flat ground where tennis is being played, and this is the like swimming pool, all those things. So the same method has been done, and the printed 3D model that we have showcased earlier has been done, and it's printed using the HP printer. So I'll go back. So it keeps loading based on what zoom level we keep. And here again we can see where the photos are and how much overlap and all those things. Okay, that's about drone deploy. It's a general idea of how to use the software. Sir.
Meanwhile, there is a question which was, can anybody use drone deploy for their project?
If you have any questions,
Anybody-
you can ask.
Yes,
So
yes.
not everybody will have, I think, access.
No,
The screen is not
yeah.
viewed completely.
Drone deploy, is it a free version or what are other similar options and
So this is a
limitations of
paid
it?
version. There are different versions are available, like based on the user requirement, based on number of images that you can upload. So this is actually a trial version. So they'll give a trial version for each email ID.
Okay.
So the trial is for like 15 days, and you can create 10 projects, not more than that,
Oh,
and maximum of 3,000 images you can actually put for each project.
okay. Thank you. Thank you, Vishwas. Prashant, hope your question has been answered. If any other questions, please mention in the chat box or raise your virtual hand.
So there are other software you can take photos from your phone and also process to get a 3D model. But like measurement will be difficult since the camera intrinsics are not actually written in the each photos. Any doubts is there,
Any
you can
free and
ask.
open source softwares? Any free and open source softwares related to
WebODM you can do, you can use, install it. It's completely open source. You
WebODM, right?
can, yeah, web ODM,
Okay.
and you can install it in your server. All what is like you have showcased in web server, like to drone deploy, something very much similar can be done by using the web ODM. And there are many other competitive softwares. Some gets technical support, it keeps getting updated. Some die down. That is the thing of open source. Some it depends on how the community goes to takes it, because the like how we have Raspberry Pi, Arduino very popular. Similarly, there were so many other open source boards, but these two sustained very well because support that the community gave and the functionality of the board itself. So similarly, software also, it varies. There are many other uh, companies which are exclusive for maybe agriculture or for thermal, which I have shared the screen now.
Okay, sir. Thank you, sir.
Yeah. So now let us move on. How, if I change the payload, how thermal drones can be used for the purpose. So it can be for agriculture, it can be for forest fire, it can be for elephant tracking. We had successful study of elephants being tracked by using these drones. Our staffs had gone over there, wherein which the over from the evening till it got tracked, our team was doing the drone surveillance in the forest of Kadaba, Subramania, where in which one of the tusker was being tracked, and then the information was shared along with the to the veterinary doctors of the forest department, and then they were able to proceed further and tranquilize. Of course, then you know that how these elephants have been sent to rehabilitation center and do. So the applications are many. Uh, you change the payload from what the naked eye sees to a thermal camera. So what he sees is different. So it will be able to showcase the temperature difference, and then the advantages are many. So in the forest department, if they want to study about forest fire or and crop health can be measured by using temperature stresses onto the plant, or it can be rescue during forest fire missions, or in the night time someone is drowned, you are not able to find, or maybe this typical example as was seen over here. Nowadays it's very popular to have solar farm. So now if you see over here, the solar farm, there's a lot of panels, 8 acres of land, and then it needs to be surveyed. So what we do is basically there are two types. One is regularly try to do an RGB, and another one is try it with this camera, or else now integrate RGB along with the thermal camera and then try to do the survey. So what will happen is basically hotspots on the solar panels will be visible. So those hotspots are nothing but the temperature stressors that are there on the solar panel. So that can be because of bad maintenance of it. It can be because of the a shadow falling onto the solar panel. It can be a physical damage that is there on the solar panel because of some stone or some droppings that fell while the bird was moving on the top. So the reasons are multiple. So the thermal camera helps to identify that and then try to do. So this was basically a students built a thermal drone. Basically what has happened was Raspberry Pi, which is an open source, and a FLIR lepton module was used, and this is the data set that we have got. May not be that accurate or that colorful as what you are able to get in this by using a FLIR module. So that is an lepton, FLIR lepton, whereas here it is an high precision thermal cameras integrated onto the drone. So now off the shelf thermal drones that I will show you. So before that, we'll try to showcase one of the video of how drones can be used for survey.
India are places of national importance and share a vast coastal area along the sea. They have a significant area to be put under surveillance for the safety and security of the territory. It is the need of the hour to adopt new technologies for the surveillance of the port to ensure safety and security in a better way. Therefore, NMPA has deployed drone surveillance at its operational area in collaboration with Center for System Design, National Institute of Technology, Karnataka, Surathkal, which will not only be useful in security and surveillance, but also in safety management, reaching risky spaces, firefighting, environmental law and order, maritime search and operations, and traffic management. Drone surveillance provides a multitude of benefits to enhance port security. The drone detects and identifies potential security threats, such as unauthorized access or suspicious movements and behavior. Can identify any congestion, unsafe working conditions in various port operations, and can alert relevant personnel. Additionally, they can inspect equipment at specific intervals based on certain conditions, ensuring that potential issues are identified quickly. With real-time monitoring of port operational events such as container handling and cargo transfers, drones provide valuable situational awareness. And with thermal surveillance technology, these drones can detect movement even in absolute darkness, improving port security around the clock. Drone surveillance will enhance security and surveillance of the port, and real-time monitoring of possible threats can be done to alert the security personnel. This will not only help the port to ensure the security and surveillance of the area, but also will help in providing a safe and secure place for all its stakeholders and the public at large.
So what you saw was an off-the-shelf drone. It's from DJI. There are drones which you can build yourself and use it. So now the applications are many, as I said. Vishwas, can you show it online?
Yes, sir. It's visible, right? So this is the drone, and we'll be able to see the payload over here. So this says, am I audible?
Yes, yes, Vishwas, please.
Okay. This payload has two sensors, which is RGB as well as thermal sensor. I'll showcase the data how it is live streaming. So hopefully it is clean. So I'll try to control the camera from the drone itself. Right now, you'll be able to see some dark spots. And if I move a little up, so you can see the spot where it is exactly showing us the fan. So the fan's middle head is actually pretty hot, and it is at somewhere around 52 degrees Celsius. And if I select somewhere else, it is somewhere around 28.8 degrees Celsius. So live temperature monitoring can be seen, as well as if I again try to control it and show some other region, we can see there are different place. So in the room where the lights are, this region itself is hot, and if I move, so you can see this is the AC in the room as well as a tube light. In the region where the AC vents are there, so this region is pretty dark because it is somewhere around 15.4 degree, where the AC is kept at 16 degrees for cooling. But the control box and the power supply unit is pretty hot. It is somewhere around 30 degree and 33.7 degrees. So similarly, in the night time, if you want to identify like somebody is trespassing in your area, or see some wildlife which is moving, so heat is one signature where we can identify through these drones. So any doubts you can ask.
Vishwas, you can show with an human body if any volunteer is there.
Hi, yes, sir. Bro.
Okay, so yeah, correct.
It can be seen like where the shirt part is there, so he's actually it's cooler. Where the body is, it is actually hot. And if he holds his shirt with his hand for a few seconds, and if he leaves, that part will be pretty hot. So you can see the temperature has transferred to his shirt. So that can be easily visible.
So this is exactly one of the way how thermal cameras can be used for agriculture, or it can be used for animal detection, people getting drowned, and we need to track them, or firefighting applications. Applications are many, maybe for search and rescue or surveillance. All these applications, thermal cameras can be used, which shows a typical way, and maybe in sometimes pollutants also. If there's a temperature difference that is getting discharged from the industry onto the river, all those things can be reduced. So it has RGB, hyperspectral, multispectral, thermal, or maybe an air quality monitoring sensor mounted onto it without any visions. Even that will also work. Thank you, Vishwas.
Thank you, sir.
Yeah, we can actually later be ready for LIDAR
Okay, sir.
before we actually proceed further and end the session. So what we saw was a typical different types of vehicles, whether it is an fixed wing. So let me just showcase one example over here. So you can see over here how there is an helicopter which is basically a remotely controlled, we call it as rotor wing. Why? Because it rotates and it doesn't have a fixed wing. You have a main rotor and a tail rotor. In some cases you have coaxial, and then it will be able to fly. It is basically a system of vertical takeoff and vertical landing. Applications are many. We can see one typical example over here, wherein which there is a vehicle getting tracked, helicopter is on the top, and there's another example wherein which there's a fire. This was pretty old work. Nowadays things have changed, but this is how things used to move. Like you have an helicopter which has an endurance, but it's very difficult to program and operate it. You have an multi-rotors. It can be quad rotor, it can be hexacopter, it can be octocopter, and maybe nowadays these multi-rotors are also being used for agricultural applications in terms of spraying seeds, or maybe using spraying pesticides, or also for maybe spraying water during the fire, or maybe so applications are many. It depends on what is a payload, how you can build an hybrid system. See, now this runs on an ethanol based system. Now we suppose if the endurance has to increase more, there are two things: whether you build an electric and go for an hybrid engine and then increase its performance and increase its endurance for a longer duration, say 45 minutes, 1.5 hours, or just go for electric, which is easier to operate and very less vibrations. The expenses comes maybe of the battery, whereas in IC engine there are other maintenance cost which comes into picture in running. But of course they can carry more payloads compared to the electric ones for the same cost benefit what I am talking about. It's not necessary that we should always use drones. This is a typical example. Hope my screen is visible. Vishwas?
Yes, sir. Yes.
On kite, it's about kite, yeah. So it's not necessary always you have to use drones. In some places, we also have gone with big kites, 12 feet kite, that 14 feet kites based on the requirement. And you can see over here, there's a simple camera mechanism which has been mounted over here, which will balance by itself with very less electronics onto it other than the triggering system. And this triggers the photo and we'll be able to do an aerial imaging. So this is a Japanese traditional kite called rokako. There is a bow in it, and that bow you need to adjust it based on the wind condition. A very less wind, it will be flat. More high wind, you try to bend it so that the air will get deflected. And there are multiple other types of kites which we have used to capture some of those images wherein which drone flying permissions are not allowed, but still kite serves the purpose. So this is how we do before we go on to the LiDAR. So you can actually refer to Center for System Design YouTube channel, um, wherein which some of our applications of our projects have been showcased. Which was regarding LiDAR. Are you ready?
Yes, sir.
Yeah. Can you share the screen?
Yes. Sir, can I get a feedback? Is it visible, sir?
Yes, Vishwas, please. You can see your presentation.
Sir, you can see, right?
Yes, sir. Yes.
Okay. So let's start with the basics, like what LiDAR is, because it's kind of new technology. A few people are actually use this. So people with iPhone actually has a iPhone, all the Pro models like 13, 14, 15 Pros has a LiDAR sensor embedded into it. So LiDAR stands for light detection and ranging. So what it does is it uses light to measure the distance from the LiDAR device to any object which is in front of it. So the basic principle is time of flight. So what time of flight is? One pulse of light is being sent in one direction, and when it hits any object, so that object based on its color or its property, it will send some of the reflected light back. So if it is white, it will send most of the light back, and if it is black, it will absorb most of the light, and some of the light will be reflected. So reflected back light will be captured by the receiver, which is along with the LiDAR transmitter itself. So now we know the speed of light, 3 into 10 per 8 meter per second. So now we know the time taken by the light is measured. So through that, the distance is calculated. So which will have the total distance is what is the light pulse is went, hit and come back. So if we do half of it, so we'll get the distance from the LiDAR to any object. So what LiDAR does is it sends up to 1 million, or nowadays it sends 2 million or above points per second, and every reflected pulse is being noted. So and it's pretty fast. So mainly its accuracy means it's very high accuracy. LiDARs will come with the 1 millimeter or now better accuracies, and can be used for 3D mapping and like flood mapping, all the things. And another advantage, it can be used in low light. So unless photogrammetry and other systems, so if photogrammetry requires some light to take a photo, some light is required. So if there is no light, there will be grains. So if it is very dark, we can't capture a photo. But LiDAR uses its own light. It uses its infrared light, So since it is using own light, you can even use it in the night or any dark weather conditions. And lidars captures high amount of data per second. It can capture up to 1 million or more than that. So large amount of data can be captured in small amount of time. So what are components in the sense? There'll be lasers and some scanners and optics, and photo detector to receive the reflected light, and the camera. So lidar, once it captures any point or it captures the reflected value, so it note down the XYZ position of the object in the 3D space. So it will only have XYZ location. So assuming I'm scanning the whole building, so I'll have the building in made up of a chunk of points, but I'll not have any color of the building. So to get the color, so we'll also have a camera. So that will take the images, and from the images, the RGB value is extracted and given to each point. Along with that, position and navigation system. Some lidar system can be used with along with the multi like UAVs or satellites, as well as our vehicles. So at that time, we also need inertial measurement systems, IMU, or we call it as accelerometers and stuff, and position and navigation system. So this is actually GPS, and there'll be tilt compensator. So people who have used total session and all will be knowing how difficult it is to actually get the water level to exact proper level. So if tilt compensator is there, so it will have an inbuilt gimbal like mechanism. So even if there is a slight change for 2 degrees shift, so it will compensate for itself, so that time will be saved on like balancing the device. This is how the basic structure will be there. So after a few slides, I'll actually live show the same device lidar. So how lidar will capture the data. So this is a terrestrial lidar. So there's a tripod, and about the tripod, the lidar device is kept, and the scanning motion you can see. So it is like a circular scan will be there. So there will be some blind spot which is exactly below the lidar device, and along with the scan which is happening with respect to horizontal, a circular motion, the device itself will rotate with respect to vertical. So we get a spherical scan. So it's a 3D spherical scan we can obtain from like terrestrial lidars. So compared to lidar and radar, so mainly lidar will give a high accuracy and better image quality compared to radar, because radar is a microwaves. So microwaves is not directional, whereas light is directional. So it can single pulse can be sent in any direction, whereas sound or any electromagnetic wave will not go in single direction. So it will also spread like water waves or like any other. So and you can see it's 100,000 smaller wavelength than radar, so which helps us to get small particles. So even if there is fog or some other particles in the air, so that also we can actually capture through lidar to maintain the like or measure the quality of air. So there are different platforms. If the lidar is attached to tripod and kept it in the ground, it is terrestrial. If it is attached to an airplane or some unmanned aerial vehicle, so it's an airborne system. As well as if you attach it to a satellite, satellite-based lidar systems. So this is the general flow chart how a terrestrial lidar will work. So there are two things that has to happen. It may be simultaneously or it can happen independently. So first lidar scan will happen. Along with that, there is a 360 image capture. So this is a surveying process. And once the survey is done, you transfer it to your computer where the post processing should happen. So here the registration of lidar will happen. So what registration is? So if you want to capture one land or one building, so with one scan we cannot capture all the area. So we capture at regular interval so that there is some overlap of first scan, second scan. So this merging of multiple scans to a single scan is called registration. So once registration is done, colorizing also can be done in the same process. So and we get a point load. So this .las file, lidar data exchange format we call it. Mainly it came from lidar aerial scanning. Okay, so that is why LAS point cloud, and this is general point cloud. So if you want to ask somebody share me the lidar data, so this is a format you should ask. Then once you get this, there are open source softwares where you can import the data and convert it into a different kind of data, also any kind of data. For example, AutoCAD works or 3D modeling, all those things. So further processing can be done to get noise filtering. So in case some bird or some other vehicle movement is there, some noise will be there. All those noise can be filtered, and you can classify the point cloud into ground, trees, and buildings. All those things. And once we done that, we can go for the final output process, where you can obtain digital elevation models. It can be terrain model or surface models. We can get textured mesh measurements. We can do any kind of measurements, like area measurements, volume measurements, all things. So there are different processing software. So if they are using Trimble, or there's Trimble RealWorks. So if we are using Faro, I'll demonstrate this. So Faro has Faro Scene, and Yellowscan, there's one more brand which has Cloud Station. So this is just a screenshot of the software, how the lidar processing software will look. So this is how the lidar point cloud is actually captured. So there's an outside and inside scan has been done, and there will be some. These are all the noise particles that has to be cleaned off. The whole surface, sometimes it looks like it's a complete surface, but the every piece is made up of like millions of points. So if we zoom in very closely, so we cannot see any of the surfaces. Everything, every wall and everything is made up of small points. Okay. If you want to use and process the lidar data, general software is Cloud Compare. So you can note down if you want to explore more about this. So Cloud Compare is an open source software where you can import multiple types of lidar point cloud, and you can process it. You can classify it. You can segment it. You can extract profiles from lidar sections, and if there are some scalar fields. So if lidar has different properties like return number, all those can be visualized, and you can also apply your own scalar field based on our conditions. All those things can be done. So this is the lidar point cloud, and from this you can see there are different outputs. The first one is like it's a scan data, and the next one is actually a mesh data. So from the scan data, a mesh is generated, and the third one is a scalar field generated by distance between the points. So the red region and the green region, uh, these regions, the distance between each point is very less. That is why to identify where the points are not uniform and where not dense, this scalar field has been generated. So where the blue points are there, blue color, there is uniform and high density of points. So this is the Faro laser scanner what we have. So I'll showcase this. So this has a so class 1 laser 1550 nanometer, and it can capture up to 350 meters and extend it up to 600 meters, and it can capture up to 1 million points per second. And with respect to vertical axis, it can capture 360 degree. With respect to horizontal axis, it can capture 300 degrees. So, and it has an HDR camera in it to colorize the point cloud. So on-site compensation is it will compensate for the tilt generated, all these things in the site itself instead of post-processing it. So it has Wi-Fi. So in case if the device is fixed to any inaccessible area, and it is sent with any robot or something, we can access this through our phone and trigger the scanning process. So it has GPS and GLONASS sensor just to find a location where the scan has been happened. Um, these are general properties, and this is the LO scan fly and drive. I'll showcase both the devices.
We will, Vishwas, we can show the video that what we have done. Okay.
Okay, sir.
Okay. Rather than showing this, I will play that. In the meanwhile, you can keep the system ready.
Yes, sir. Okay.
You can unshare it.
precise, accurate, and fast. Though traditional surveying solutions are accurate, they are time-consuming, consequently paving a path for advanced surveying solutions which is highly accurate, and also consume negligible time when compared to the extent of data collection. Drive LiDAR is one such instrument which provides accurate and detailed information of the scanned area. The system can acquire highly precise 3D measurements of road surface, tunnels, buildings, vegetation etc. that surround the road while the vehicle is traveling. The compact lightweight Drive LiDAR system takes less than 5 minutes to set up and mount on a vehicle, and is also incorporated with high-accuracy GNSS and IMU for precise positioning. The LiDAR core is fixed to the car pod, with the help of brackets, and a GNSS antenna is attached. The drive pod can be attached to the vehicle using suction cups. Differential GPS is used to establish the ground control point for the entire session. The system can be placed at any suitable location near the area to be surveyed. The LiDAR sensor has a 360-degree field of view which can capture its surrounding area while the vehicle is moving. The scanning of the data can be observed wirelessly in real time, using the live station software.
You can see over
Direct
here,
georeferencing software,
stops,
as well as point cloud
mounting onto the
registration,
vehicle and
are
then
used
using
to
it.
post-process the scanned data. The output of the survey is
So
highly
this is actually
precise
how
3D
NITK
GIS
campus,
map data.
where in
The
which
processed point cloud
point
can be
cloud is
exported to
showcased.
LAS, laser format for general applications. The data is used for the creation of DEM, road inventory creation, topographical surveying, map creation etc. The utilization of these data is very vast and spread across various departments, making it the need of the hour.
So you can see here,
NITK, being one of the pace
are
setters in
out
taking
of it.
forward the technological advancements in the country, now owns this state-of-art instrument funded by the Central Research Facility. Center for System Design uses this unit to execute various projects, spread across diverse domains, to meet the requirements of their respective projects.
Yeah. So this is how we are able to do the drive LiDAR, aerial LiDAR, terrestrial LiDAR in combining with the different other applications. Vishwas, I can just show those units by holding it.
Yes, sir.
Yeah.
So this is a terrestrial LiDAR unit, Faro. So here you can see a mirror which is inclined at somewhere 45 degrees. So all the the sensor components are over here, and it is actually sending pulses like this. And this mirror will help to get data around this axis with respect to the horizontal axis. So the scanning is being done, and the whole device will rotate with respect to vertical axis 360 degree, so that a whole scan has been done. And in the same place there is also a camera system, so it will take images at regular intervals, short intervals. So all it combines to make a 200 megapixel 360 image, so that can be embedded in the software to get a colorized point cloud around us. So here
Vishwas, you can show the drive LiDAR to
yes,
3:30 the time slot. You can actually, is it locked?
sir.
Did it get locked when you kept it?
Yes, sir.
Okay. So what you can see is the drive LiDAR, which you saw it in the recent video, how the entire system is. And the top portion, which is bluish in color shining, can be removed and mounted onto the drone. So that is why we call this system as fly and drive. That time, this is almost 4 years old now. It almost all this complete package costed us near to 2 crores setup, but the data set that we get is very accurate and very precise, and it is extensively being used for the survey. So So here you can see how the terrestrial lidar or the aerial lidar or the drive lidar. Of course, now in the aerial lidar you have some of the products from DJI. We actually also use the main product that we are using is Yellow Scan. It's an European product, um, and there you can find it can be integrated onto the drones, or either you have built or maybe off-the-shelf drones, and then connect it and use it. So on our YouTube channel, Center for System Design can be referred, or maybe can go through some of these applications of survey, some of them which we have uploaded it, and then how we are extensively being used. So what you saw in the entire presentation was basically the works of all the students and staffs of NITK, and not outsourced work was showcased, so which we are always proud of. The works which they are doing, every MTech thesis become one work. Vishwas has developed a product essentially to come up with a cost-effective product. Vishwas, you are online. If you can showcase the product.
Yes, sir. I'll get.
Yeah. So he has just completed his thesis and submitted it for evaluation. He is MTech by research, who is a project staff also, and does the MTech along by being as a project staff. So similarly, there are many project staffs whose all these works have become a part of thesis, as well as solved some of these issues which the government agencies had given to us as a work, and which we are able to complete it. They complete their degree, we get the work done, we also able to buy a few equipments and keep on updating it. So Vishwas, you can showcase it before we wind up the entire session. Yeah, so you can see how he has 3D printed it, and there's a GPS system over there, and then there's a Ricoh Theta camera, which is an 360-degree camera. So there's a small servo which is connected to a controller, which triggers the photo as if we are clicking it manually. So of course now the updated versions of cameras have come. So this is a 360-degree camera, lenses on both the sides. The higher versions of them have been released. So what was existing in the lab, he has used it and integrated so that we can be able to get a colorized point cloud. This entire product cost approximately less than 3 lakh, if I'm right, including
Yes,
3D
sir.
printing, GPS, integrating algorithms using open source and using
Yes, sir.
it to create a point cloud. Whereas the same system was purchased off the shelf, would have at least 10 to 15 times costlier. So that is how we make students and they get involved and develop some products. And then we utilize it for actual works and also get considerable amount of outputs. So thank you for giving the opportunity wherein which we could share some of these applications and then showcase what is that we have done.
Thank you very much, sir.
Yeah.
Such a wonderful and voluminous presentation with live demo and operations of drones and its applications in various fields with you and your team that NITK is carrying, sir. Thank you very much. A round of applause to you and your team, sir.
Thank you. Thank you. Thank you.
We will be conducting such physical programs also in our Bangalore, sir.
Okay.
We
Okay.
will try to invite you, sir. That time we need your support for these hands-on training and live demonstration of drones in various applications, sir.
Yeah. Is it possible for your team to visit over here before the rainy season, or because during rainy season we can't show any demos?
Yes,
What
sir. Yes,
happens
sir.
is when we come over there, we may hardly able to get 1 or 2 drones. But here we have different size, around multiple drones for different applications. Maybe a 1 day session or half day session, and walk through the lab and laboratory and the search site.
Fine, sir.
And yeah, we are open.
Few of the participants would like to visit individually, and if possible, from our end, we will try to
Yeah.
come with all the teams.
Okay.
That we will try to arrange before monsoon or after monsoon. That can be done. Thank you
Okay.
very much, sir, once again for
Thank you.
accepting
Thank
our
you.
invitation and being part of this 3 days workshop. Thank you, sir. Thank you.
Thank you.
Both are 27-inch.
Thanks to Vishwas and Manish also. Thank you.
Vishwas, Manisha, Aishwarya. There's another big team. Around 50 staffs are there.
Yes, sir.
These are the people who participated today.
Yes, sir. Thank you, sir. Thank you very much.
Thank you,
Few
sir.
of the participants unable to join in the WebEx platform, and they are in the YouTube live channel.
Okay.
And for them also, we would like to thank you, sir. So
Thank you.
now moving to the next session, Dr. Uday Shankar Puranik sir is with us now. Before starting the session, I would like to give introduction about brief introduction about him. Dr. Uday Shankar Puranik sir is Director of Artificial Intelligence and Cybersecurity, working for MGI in USA, and he is a Kannada passionate science writer. And his academics and professional summary are as below. He has done his graduation in engineering from Bangalore, masters in computer science from UW Madison, USA, and Doctor of Engineering from Cranfield, UK, and Doctor of Engineering from Brown, USA, and Doctor of Engineering from CDE, Singapore. He is an expert committee member for cybersecurity at the following international organizations, out of which I would like to mention few here: BIS ISO Subcommittee for defining cybersecurity standards for UAS civilian and military use, ATMSA Sioux Falls, USA, and European Union Agency for Cybersecurity, ENISA, Athens, Greece, and Military and Aerospace Cybersecurity Group, USA, and IIoT Consortium Cybersecurity Group, USA. He has been involved in product framework developed for such as cyber forensic analysis of advanced persistent threat APT and DDoS attacks, and artificial intelligence enabled extended threat detection and responses, which is known as XDR, and cyber physical security for Industry 4 and MedTech. And apart from that, cyber intelligence framework, electromagnetic spectrum operations for space and military applications. He has brought 37 years of experience at senior management level in global IT industry. He is internationally certified ITIL 6 Sigma security and project management professional. He is an advisor in cybersecurity and artificial intelligence to governments, multinational companies, universities, and institutions across the world. Apart from that, his professional activities involve as he is a member of IT panel of CIA Karnataka for 2 consecutive terms, and executive member of Kannada Ganaka Parishad, and has in the past 26 years developed a Kannada language software for use in television, ATM industries, web portals, author of more than 3,500 articles on IT and new technologies, which are published in leading newspapers and publications, author of 6 books on technology and research. He has set up and managed a RAM design team in Bangalore, which developed for the first time a major and successful DRAM design outside the Japan. He developed a software for ultrasound scanning, MRI, and CT for healthcare. Have given 150 episodes about cybersecurity awareness for common man from G Kannada News Channel. He has given more than 200 radio, television, and webinar programs for students about new technologies like artificial intelligence, Internet of Things, and cybersecurity. Apart from that, his academic activities are as follows: Honorary Fellow at Karnataka Science and Technology Academy, Government of Karnataka, Member of Board Studies for UG and for PG, VTU Karnataka, Member of Academic Council, Central University, Vijayanagaram, Andhra Pradesh, and he is a member of Expert Committee for Engineering Textbooks in Kannada language as per NEP at VTU Karnataka. He is a member of Governing Council at National College Karnataka and Chief Editor of Encyclopedia for Computer Science at University of Mysore. And he is a member of Governing Council, Nagarjuna College of Management, Karnataka. His major awards and recognitions are Karnataka State Government Award from KSTA for year 2018 as one of the best authors in science and technology in Kannada language for the book on artificial intelligence and opportunities it offers. He is a prestigious Eminence and Excellence Award for exemplary contribution in information technology from IBM, and Lifetime Recognition Award for contribution in science and technology, Kannada Sangha, NAL Bengaluru, and awards and felicitation for innovation and contribution in the field of information technology from several government, multinational companies, professional organizations, and institutions. With this brief introduction, I will once again welcome Dr. Uday Shankar Puranik sir on behalf of KSTA, Manage, and on behalf of all of you, all my colleague participants. I welcome you, sir. Over to you, sir.
Thank you very much, Umesh, and thank you all. And hope I'm audible to everybody.
Yes, sir. Yes, sir.
So today I'll be talking about cyber security, particularly in unmanned aerial vehicles. The other popular term for that is drones. We don't use the word drone from the industry, so I'll be limiting myself to UAV. Now here I'll be sharing the certain information more from the agriculture applications perspective, and
Yes, sir. We can see
it's inverted here.
it's in inverted.
I made a brief presentation, but hopefully there will be many questions from the audience. I'll try to answer that within the given time frame. So the objective is we have to look at UAV from application perspective, because we look at the application layer, then we look at the data layer. Let's see what let's do. Hope the screen is visible to everybody. We have many challenges.
Now it's perfect, sir. Please continue, sir.
Thank you. Thank you. See, primarily, when you look at UAV use in agriculture, we look at multiple applications. Of course, many are already being done, and some may be in the pipeline. But everywhere we look at multiple layers, primarily from cyber security, not so much from information security. Ecosystem of the device could be one or could be of a different types altogether. It may be one single type of UAV being used, but then there are different types of UAV being used, and it may also be integrated with a wireless service network. May also be integrated with a wider ecosystem, maybe with the satellite network, where it's GPS denied environment or communication are not up to the mark. So what I'm trying to say here is, while applications are growing and number of devices are also being manufactured extensively, there's an increasing need for ensuring that this entire system is secure. Now, as a part of the subgroup on cyber security for Yes, under Bureau of Indian Standards, I and my colleagues have defined cybersecurity policy for use in UAS, both for civilian and military purpose. And this has been published on the BIS site. You can go through that, and any feedback would be more than welcome. So, to the best of my knowledge, this is the first global standard defined, probably adopted by ISO in the coming days, and that way we can all take pride that we Indians have developed a standard which should be adopted by the rest of the world, particularly in a very complex and competitive field like cyber security. So that can be a benchmark for all the people. One is people who are manufacturing UAV either in India or abroad and trying to market them in India. Second, people who are service providers for the different applications, and people who also kind of do the data analysis and analytics and integrated with AI or IoT systems for further processing. So any of the type of usage, guidelines are pretty clear in the draft policy. You can go through that, and any feedback, please do share that, and that will be considered by the executive BIS committee. So with this background, what I'm trying to say is, from across the world, we look at major threats, and not because the government, because it kind of undermines the agriculture economy by some unknown people collecting it and misusing it, or kind of using it against our own country. So how do we stop this, or how do we identify that this kind of surveillance is happening, and how do we mitigate that and take action against that? That's one. Second is smuggling or contraband delivery. That some instances you have already been saying where across the border terrorism is being supported, and also drugs and contraband delivery is also happening. Now, our fear is it may also be kind of used to, spread certain uh, virus or certain kind of diseases which may be affecting our crops and also the fertility of the soil, and thereby create a loss in the yield or also agriculture prices by it's all manually created. So one is climate, and the second is certain forces which are against our country may be involved in this kind of activities as well. I'm not talking very big about biological warfare or chemical warfare here. At the same time, we can't rule out some terrorist elements trying to resort to that as well. So there is one more area where it's a concern. And third is where a government business. It could be, for example, where a government is procuring the food grains, storing it and marketing it, or distributing it to the public distribution system, or for any different welfare systems. And even the finances being provided by the government directly or indirectly to the farmers and agriculture companies. Now, there could be a willful disruption in that. I will be going into certain possibility things. I'm not saying all this is happening right now, but it may be a potential threat. And we are not. Audio is. Okay. Audio is little. So, audio. Okay. You don't have a mic, okay? I'm using a monitor mic out here. So probably that's a challenge of mine. Did they try to change the settings? Is it better now? Hello. Are you
Please continue.
sorry, somebody said something.
Continue, sir. Now I'll check and inform.
So last one is there may be deliberate instances where fire is being caused and could be using chemicals or could be using certain arms or ammunition across the border, again using this kind of vehicles for transportation or even a suicidal drone kind of attack against our grain storages or even harvest ready crops or our research institutions or any place which they feel is a potential target. Now, these are common threats what we take when we look out cyber security, not very specific to agriculture, but what we understood from the agriculture threat across the world that I tried to include in an upcoming slide. Now, this is something that's happening. We generally look at a cyber attack as some guy sitting somewhere and trying to manipulate a system, but we classify it as multiple sections. It's not very exhaustive, it's just indicative. One is, they try to attack the data which is being collected by the drone or the entire ecosystem itself. So it may be, trying to collect already the data which is already we have collected using the system. They may be trying to tap that and try to take that, or if you are trying to store it in cloud, then they may be trying to access the cloud and take it, or they may be trying to inject data. Now, this is a very scary situation because that will lead to data manipulation, and we may not be getting correct data. Even though the vehicle has been moving around, doing all the work, and we believe all the systems are working fine, but if they manipulate the data or either delete it or modify it or deny it, then it can really create a problem. So we talk about false data, we also talk about misinformation. So these are some of the typical data attacks which they have tried in different countries, particularly targeting the agriculture. Now, same way we can look at a networking and equipment attack. Now, since it's a radio frequency, they may be trying to jam that, or they may be trying to inject a certain malware, which are very small file size and which act on a certain triggers, and they can actually bring down the entire system. It may be a denial of service, or it may be even worse than that. It could be a ransomware or anything else. And one of the challenges what we face from cybersecurity industry is the type of malware is becoming more and more destructive. Earlier, it was just trying to steal information or trying to stop a system being used. Now they're destroying the data and they're also destroying the systems. Now that can be very expensive, and also it can actually put clock backward on established systems and data, and it can be really big loss in terms of the system and also the cost wise as well. Now, we also discussed about DOS, that denial of service attack, and botnet attack is where the possibility of using swarm drones. Instead of using one drone, they may be using a swarm of drones, which are not easily recognizable, and try to create a massive attack across a wide region, maybe an entire state or an entire district, if not entire country. In small countries, they may be even trying to do it across the country. So side channel attack is where basically people are trying to overhear or steal data packets and voice data and trying to misuse it against the end user. Now this is on the user perspective, primarily user side, where we talk about data and networking. The downstream, that is where the supply chain attacks also happen. So they may be targeting third parties in the entire supply chain of agriculture, or they may even be trying to give a wrong kind of a software update and try to bring down the supply chain softwares being used. And they may even fabricate data and try to create confusion in the supply chain. And they can also try to use the supply chain to create a major cyber attack against vendors and also all the stakeholders in the same system or even in the kind of a relative system or which is actually in a way connected to this system. Now, these are some of the scenarios what we look at it when we say cyber attacks. Now, this obviously can't be done by one person or one organization. I'm not going to deviate here saying who is doing it or what is happening. Can you find out? Yes, if you are reading certain prophecies or a certain point of view in the newspaper from so-called cyber experts, then cyber attacks cannot be stopped. Cyber attacks cannot be found. Who did it? Cyber attacks criminals can never be punished. So it's a very, very losing game. But reality is you can actually predict a cyber attack happening 30 days in advance. So many technologies are available and systems are also being set up in India in a very big way. So we are trying to predict and prevent an attack even before it actually happens. And in the worst case, it does happen. There's a lot of incident management and mitigation technologies available. They do take care in limiting the damage being caused by any cyber attack. And the third part is where we investigate. We call it cyber forensics. Any attack, irrespective of it being done in India or from outside, can be tracked to the person who actually did it. So technologies are available and a lot of investment is being done by the government of India and a lot of hardware, a lot of professionals are also being engaged in this. So I can assure you at this point, without getting into too many details, that we do have one of the robust cybersecurity system as compared to any other developed country in the world as of now, and we are trying to improve that because this is a field where new attacks are happening, new players are coming, and obviously we have a serious threat across the world against cyber terrorism. So I'm not getting into that part of it, but what I'm trying to say is, yes, there are challenges, but at the same time, as a country, we are pretty equipped to face it, and we are continuing that. We're continuing the work on that and ensuring that it's safe to work in our country and the data is safe and people are safe and also all the activities which are required for our country are not really affected by however malicious person or group or state-sponsored terrorism. State-sponsored terrorism, we don't use the word cyber terrorist. It's primarily cyber criminal gangs or organizations which are sponsored by certain countries. You all know who these countries are. They're sponsored, they're funded and protected by these countries to launch large-scale cyber attack or even support terrorism, support drug cartels, support human trafficking, support illegal transfer of money, and a lot of anti-national activities against a target country. And we are one of the target countries, so are many countries. So it's not specific to India as such. It's cyber terrorism is a big challenge for the entire world itself. So with this background, I'm just trying to explain where we are coming from. So you mentioned about communication. Now, if you look at data or anything they're trying to do here, we classify it as different layers here. One is this is what we call as L1, which is primarily a communication link between the UAV and with another. In case you're using more than one UAV, then how do the both UAV communicate? We call it as a L1 communication link. It's primarily based on IEEE standard of 8.2.11. Second one is a L2 communication, that is between the device and the base station. And third is L3 communication. It corresponds to the connection between different base stations. Now, fourth is where we're talking about connection link between GCS and base station. Fifth is communication between wireless network and base station. And the last one, L6, it corresponds to link between ground user, that's the operators with the UAV. Now, when we talk about cyber security, we try to cover all these areas. I just give an indicative numbers for people who are not very conversant with this. We do consider all these communication links and more right up to the chip level or the firmware being used in any device, any equipment, whether it is airborne or on ground or through wireless or through even satellite. So it's a very holistically we do consider that. So one, we ensure that the communication is safe against any type of cyber attack or cyber terror. So different type of UAVs, obviously my earlier speakers would have already explained this. Now we take it on type of classification. So some are called small or micro devices, some are called low altitude, low endurance, some are called medium altitude, long endurance. Now we also have the high altitude with long endurance and high altitude, long endurance and low observation. Now you can classify UAV depending on the category or depending on the use or depending on the way the local laws classify them. I just taken a generic part of here and just an indicator of who the major vendors are. I'm not claiming for any vendor or speaking for anybody, but sometimes because of the names being very popular in media, maybe easier to relate any vendor or any particular product type. Now, what really is there in a UAV? Again, from cybersecurity perspective, we are not looking at from the device architecture part of it. So we basically try to look at it from communication channel. I already explained what are different type of communication channels we are considering. And if it is connected to satellite link, we also look at what is happening with the satellite link part of it and how the satellite is safe. Or if it is a radio or mobile station, or it's also connected to any IoTs. And of course, a common thing would be ground control and command. Now, in each of this, not just the application. See, application layer is one thing for us, but we also look at the operating system. We also look at the data base or data layer in there. And we also look at any firmware or hardware which is already being hard-coded and used in the device. Now, any change in configuration, any change in any hardware, device, something was not working, somebody replaced it, all this needs to be documented. And common mistakes we have noticed is people don't document what they change when, and when there is an incident, firefighting that, and going to the point, finding out who could have potentially used a loophole and launched an attack. That's very time consuming and also delays the process of finding out who the culprit is and taking severe action against him or her. So my suggestion here is to please do document. It is not enough if you buy a device and start using it, configuring it and do that. From day one, please document it from what are the factory settings and what changes you have done. And if you added on anything, please do document that. And if you have any changes as a part of routine maintenance, you are upgrading a software or you're upgrading memory or you're changing some hardware, peripheral in that, for whatever reason it is, please do mention very clearly what are the make, what are the reason, who did it, who tested it, and who okayed it. Everything should have a test plan. You can't just say that somebody has done it and it all works fine. Please don't do that. It's in your own interest only. Please ensure that you have a documentation, or if you are not the person handling it, ensure whoever you have outsourced this also does this. And one of the things what we have suggested in the UAV standard from BIS is to have a robust third-party audit from cybersecurity perspective. So irrespective of whether it's a made in India product or a sold in India product, it has to go through a cybersecurity audit because numbers are increasing, and we also have the threat of runaway devices being made by people who are not actually registering them as per government guidelines and who are unauthorizedly trying to fly them and create a problem for others. So this one more thing, and again, as I said, from a cybersecurity perspective, we look at what is there from the hardware part of it. Generally, it's SBC, that's what we call as a single board computer, which primarily has a CPU and memory. And there are sensors, obviously, with that. Then you have battery, then you have RC receiver and transmitter, telemetry, and flight controller. Now, these are typical components of UAV. And extended, you can add based on the application. You can add a thermal or a video camera or even chemical sensors based on the application. And the ground device, primarily it's a client terminal, which uses a RC transmitter and telemetry. And there's a GCS, that's a ground control system, through which you can also connect to a satellite. It is beyond the line of sight. If it's beyond the line of sight, then you can use that. If it's data link, you can use it within the line of sight. So these are typically what we look at, and whenever we say cybersecurity, we try to ensure each of these things are cybersecure. Now there are different methodologies for it. I'm not getting into the details of that, but please do ensure that all these are to take the help of some cybersecurity expert or organization and ensure these are all really made cyber safe, irrespective of the time you have been using it for whatever purpose, research, development, or commercial use. Please ensure these are all also cyber safe, and you are safe, and the country at large is also safe. So what really happens? Where do the cyber terrorists or cyber criminals try to attack? One is on the flight control, or could be on the gyro sensor and camera placement, or it could be on onboard flight communication module, or power supply. Now, power supply is happening because they are trying to attack the battery charging and the management system. You have the BMS thing, battery management system in your device. So they are trying to target that. So it shows as if the battery is fully charged. But when you start flying the device, probably the battery is not fully charged and it can lose control, crash somewhere, or they may create it to crash somewhere, or they could even be, trying to manipulate the charger settings itself so that the battery itself gets destroyed. So these kind of attacks are happening. I'm not trying to scare people. I'm just trying to talk about different scenarios here. So when we look at cybersecurity, please look at all these things and ensure that you get a proper audit. Audits primarily talks about as-is condition. There may be certain gaps and certain recommendations by the cyber expert who have done the audit. Please do take action against them, particularly the high priority observations. And of course, it's difficult to convince management, finance, everybody, but it has to be done. So that's the situation right now. Now, we also talk about, why do we require something like a high altitude or drone or low altitude drone? In both the cases, whether they're using it for high altitude surveillance or any cross border terrorism against any agriculture assets of our country, not to be identified or not to be tracked easily, they may use both of any one of this, or they could even use a swarm. Now, swarms so far they are not used in the country, but we do fear they could be attempting to use high altitude or low altitude drone, and it's whatever preventive actions are being taken to identify that and deactivate that. So the threat is still there, but the question is what I'm trying to say is how do they do that? Now if they're using a high altitude drone, then I'm using a similar drone to control it. A similar drone could be flying across the border, and using that they could be trying to control this drone which has crossed the border and try to fly on a target area in our country. So that's one way they can do that, or they could also try to use a satellite network, and wherever it is possible, they also try to use the cellular network. Now, what it means is whether it's a low altitude or a high altitude thing, there are people who are kind of sympathetic to them or working with this kind of anti-national elements and creating problem for our country at large. They may be within the country. Now, action is being trying to taken to identify who these people are. Now, what do they do? How do they do this? They're trying to run their own drone and try to support this kind of illegal activity. Then they use unregistered drone. We call it as a flyaway drone or a rogue drone. Now, rogue drones most of them are assembled, not really brought out from a particular product company or something like that. So they try to assemble them and fly it at a low cost, but it can still be dangerous, though it may not be directly creating a harm. They could be supporting something across the border being used in our country. So we are trying to find out where these operators are and where these are getting assembled, and to take action against them by using the cooperation of state government, police, and any of these things. Wherever you find a satellite phone call being received, or some unauthorized drone flying out, or somebody trying to attempt to break whatever the rules of our country, please to communicate to the nearby cyber police station, and they will in turn inform to the different agencies who are working on providing this kind of UAV security in our country. Now, what do they do? I just try to put certain scenarios here. Now, if they are controlling signals, what they can do? Now, they control the signals and try to crash the drone at highly sensitive places, or even hurt people. It may not be just a political personality, it could be even a farmer's family, or even farm workers, or anybody involved in agriculture. They might try to really hurt them and create a scare there, or they may be trying to crash it on a particular place just by controlling the signals. Now, second is spoofed signals can actually, guide the drone to move in a wrong direction, and they may try to take over the drone either through a satellite or through another drone, because it's a predator drone. Or they may also try to hack the videography and pictures and give us false data, or acquire the telemetric data and information what we are trying to get legally through our devices. Now, one of the other things is signal jamming. Wherever there's a highly sensitive area or jurisdiction, they may try to jam the signals, and what is primarily a device which has to be used for agriculture may be kind of hijacked and used against a sensitive area to record information or try to create problems in the sensitive areas. Now, all these things are possible. Now, some of these are also unfortunately happening in some countries. So wherever it's happening, anywhere in the world, we try to look at that and try to take action to prevent that from happening in our country. Why I'm sharing all this is general awareness about all this is to be improved, particularly among end users and vendors. I think more awareness is required, but in the limitation of the time what I'm allocated, I'm trying to briefly give an overview of all these things. Now, this is typically a cyber attack, or we can talk about multiple cyber attacks. I'm not giving cyber terror here, but I'm talking about how different terrorists, cyber criminals in the country and across the country can collaborate and create a massive cyber attack against the target sector like agriculture. One, they may be flying a illegal drone at a very high altitude and trying to take control of whatever drones what we are using in our application, and thereby create problems. Or they may be using spook signal for that, or they could be using malware, or they could be using jamming of signals, or they may be doing controlling of signals. Anything, it may be happening individually, or it can be happening collectively. Now, here I'd like to share one thing. No cyber attack happens overnight. There's a lot of dry runs that happen, and we have to always look out for this alerts whenever there's a dry run. And that's the reason I'm so confidently saying that any cyber attack can be predicted at least 30 days in advance. And most of the cyber attacks, massive cyber attacks, take at least 6 months to 1 year. And preparation for any cyber attack is very, very expensive. It's not easy, and obviously not done by a person sitting in a garage with a computer. That may look good in a movie or a novel, but in reality, one person sitting with a laptop and mining Bitcoin or doing something else is not really possible at all. So all these attacks are unfortunately managed by international cyber crime groups with some assistance from other organizations who maybe for whatever reason shaking hands with them and try to be in our country or any country and work against the interests of the country. Now, this is a general case. I'm not talking about a worst case thing. Worst case could be still more. I'm taking a general cyber attack, which is easily manageable. Even though they try to do all this at the same time, we can still bring them down and even track them down and limit all the damage what they are trying to do. Now, worst case scenario, if everything fails, let's say our communication channels are failed, our control over the devices are failed, and even our satellites are not able to communicate with any of these things, and even all the preventive measures what we have put are not able to actually bring them down, then that's another worst case scenario what I would say. But be rest assured, we are prepared for the worst. That's all I can say in the interest of national security. I can't get into too many details, but we are prepared for the worst, and we're always trying to learn from what is happening in other countries and improving our security. Now, this is a typical thing. You can, if your colleges are there, you can actually stimulate this on the lab level itself. Maybe your students can get a basic hands-on thing, or even vendors can also try to do this. Don't do very major attacks. Try to stimulate denial of service on attack. You can try to disconnect a remote control and try to bring down the drone. Don't have to actually crash a drone. So they can stimulate this thing. A lot of stimulation software are there. If anybody is interested, I can share that after the talk. Then this is primarily using a remote control laptop and trying to control a video feed. This again is not so simple, but what we're trying to say is you can again try to simulate this kind of scenario where some insider is trying to compromise your security and try to share the controls and also the drone video feed and data feed with the cyber criminal. So how do you identify that? You can conduct this kind of simulation scenarios within your own organization, so that it's much easier to find out if some insider person is trying to compromise cybersecurity from within your organization. Now, this is primarily where satellite attacks are being done, where they're trying to use massive technology here. I'm not going to how it's all been done, but what I'm trying to show here is how they are at a very, very high level, how they're trying to do all this. So you have the GPS signals, which are genuine coming from the satellite, and they're supposed to be recognized for the ground control system, and it's either way. But the question is like when the spoof it and the ground control signal recognized as a spoof signal, then the device, the drone, start responding to the spoof signal instead of trying to respond to the actual signal. So for that, they use high-level antennas, which are unfortunately portable. You can take them anywhere and install them and try to do this kind of signal jamming, and very technically advanced ones, and where they're able to create the jamming frequency and also give a signal spoofed one. So we have to be alert there. That's where we talked about making our communication layer cyber secure. That's what we were working on, and this is something that can be easily identified, irrespective of who that person is, whether working from India or outside India. This can also be identified, and most of them are being tracked, and action is being taken against them. Now, what are the common threats if you look at purely from agriculture perspective? One is they may try to capture the data. Second is denial of service. A lot of vendors are now trying to provide drone-based services. We have drones with attachments which can be used for spraying the liquid fertilizer or insecticide or pesticide. So a lot of people are trying to get into that now. They may try to jam those things and make sure that these things are not working, and it's a kind of denial of service. Or it could be man in middle, where they're trying to steal information. Could be data, audio, or any picture or video feed. Now these are again common threats. I'm not going into two specific things out here, but any threat is a threat, big or small. From professional perspective, there's an answer for every threat, and most of the things are available in open source. So you don't actually have to buy very proprietary kind of things to set up a basic level cybersecurity lab or cybersecurity test bed. You can always do that. It will be probably at one level, And if you want to really scale it up and you have funding from the government or the universities, you can try to make it and even offer that as a service, providing cybersecurity as a service. That can also be a initiative for any entrepreneur or organization to people who are actually using the UAE for agriculture. Now, we generally try to put it in a very symbolic way, and this is how it works. It can be a non-invasive attack, it can be invasive attack. So we try to classify that. Now, what I mentioned earlier is where they put a malware which acts on a trigger. Now, what is a trigger? It can be a zero-day attack, or it may be triggered by an external trigger. We may not have this attacks happening or malware being active all the while. It may be triggered by the cyber criminal himself. We call it as a command and control center. So he will be using a botnet, primarily like devices which are compromised and taken control by the cyber criminal across the world. He may use that botnet and try to trigger a malware attack or any of the cyber attack. And now tracking that back and trying to find out who did it is possible. It will take some time. That's what I'm going to say. Yeah. So it can be physical, it can be remotely operated, it can be created by any malware that has got into the system, or it could be by external spoofing or external jamming. So when we say cyber security, we have to cover all these things. Your device, your operator, your stations, your connectivity, your whatever communication you are using, everything should be made secure against all those things. And this is a very primitive, basic level I have taken. You can, based on your requirement, you can try to make it more and more, but don't overkill. Don't overkill. A lot of people try to spend a lot of money on making every device very secure and all that, which may not really be used for your application. So please take the help of a cyber expert and try to decide what is really required for your application and limit to that. And again, as I said, most of it is available open source. Only you have to configure it, test it, and make sure it is meeting your requirement. Now, what are the defense we have done? What we are trying to do is this is across all India network and also for most of our research organizations and the universities, and also for companies which are in agri-tech. It's across the pan-India kind of a defense network being put up. Now, one is a wireless network encryption. So this, if you are connected to any wireless service network, then it's encrypted, it is safe, and highest level of cyber security is being used there. And there's also this intrusion detection system. I mentioned that how do we know that somebody is trying to get into a network, or how do you know beforehand what they're trying to do? So that we use one of the tools here I mentioned. It's called as IDS or intrusion detection system. There are multiple types of IDS. I'm not going into too many details there. And for us, from agriculture perspective or even UAV perspective, what is important is a moving target defense. Now, moving target defense is where the characteristics are changed from static to dynamic, and that's increasing the complexity for any cyber criminal to attack. For example, one of the things that changes is the IP address. Instead of making it static, we change it into dynamic, and we also mask it. So when somebody is trying to take control of your IP, it's not so easy for him or her to do that. And now there are different ways we get into most of the defenses, but I try to take care whatever is possible. Now, again, as I said in the beginning, we try to take the system environment at every layer on what is your application, what is the scenario or service, what is the planning layer, what is the flight management layer, what is control, and what are the sensors and actuator. So this purely from system environment. This from the device, I mentioned about batteries being hacked or battery chargers being hacked, flight control, GPS, the power management model, then motors, propellers, sensors, whatever you're using in your device, that's being made secure. And this entire ecosystem, the device, the base station, and the ground control station, and if they're using GPS and connecting it to the satellite, practically everything, and more important is interdrone. Interdrone, that's irrespective of the manufacturer of the product. the drone should be able to securely communicate between each other. So that's one area we try to work on. So holistically, that's what we are doing from cybersecurity. And of course, there are challenges. Still more work has to be done. Some of the things were already implemented for air traffic control, primarily used for civilian and military aircraft. We are trying to see whether these things can also be implemented in UAV, particularly for applications which are important for our country. Some work is going on here. Again, I can't reveal all the work in the interest of national security, but there is some work being done in the country and also in collaboration with different countries, because I'm also in the expert group of many of this initiative on cybersecurity. I thought I'd share this with you, just in case you may come across a question that, oh, what, nothing is being done in GCS communication or ADS B communication. You can always explain to them that some work is already being done. We are probably working on the track. Now, this is a very complex technology, so I can't really put a timeline for that. But we want to do it independent of any foreign vendor, because this will be very critical for our country and our country's security. We don't want to actually buy something from a foreign vendor and be dependent on them for updates and versions and things like that. So some effort is being trying to do as a Make in India initiative itself. So this is some of the initiatives we have taken for people who are wondering what is ADSB. It is primarily automatic dependent surveillance broadcast. It's primarily used for air traffic control. So we are trying to see how drone users also can use it without any additional hardware requirement or plugins or any additional subscription to any plans on a GSM network or anything else. So on a low frequency, it can operate. It can work on a 1090 megahertz, and it's a digital protocol. So pretty standard identification navigation data used for aircraft. We are trying to make the same thing available for drones as well. And some of the drones in different countries, including ours, some of the drones are already started using ADS. Now we are trying to make it for smaller drones or whatever drones you may be commonly using or any user may be using. We want to bring it across the board. That's a plan. So again, worst case scenario, you do have identified somebody is internally or externally trying to have a hack into your system or try to connect data unauthorizedly or try to manipulate your settings or try to take control of the device. Then this is what we do from cyber forensics. It's a pretty standard process across the world. So collection of data, including devices. Now devices, I mentioned all of that. It could be the ground control station controller. It could be chips being used in the drone and any mobile devices you're using, and also the memory card. Now, based on the requirement, they may also ask for more details. But this is typically what the cyber expert would like to look at from devices perspective. And using that, they try to collect all the event logs, flight logs, and media files. And we analyze all this information from this data. We try to stimulate what all happened before the data was lost or the drone was kind of hijacked or crashed or anything. We stimulate the entire thing. And in stimulation, we also try to recreate the flight path. If at all, predator drone, if another drone is trying to control or hack into your drone, we can also find out its flight path, from where it originated, who operated it, and track down who actually did all this. Now, evidence validation, visualization, or route chart, that's what we mentioned, route chart, we try to do that, and documentation. This will all be submitted to the concerned law enforcement agencies so they can process it before the court of law and ensure that stringent punishment is provided, given to the cyber criminal or criminals or cyber terror organizations inside or outside the India, which have involved in this kind of cyber attack. So this is the holistic system what we have in place. So I'll rest my submission here, and if you have any questions, please do feel to ask. You'll have to ask your question because.
If any questions, please mention in the chat box.
No, I'm unable to see the chat here. You have to stop sharing them.
No, sir. No, sir. It's available. But as of now, there are no questions mentioned in the chat box. If there are any questions related to topic, please raise your virtual hand. Any questions? If any questions, please mention in the chat box.
It's okay. If you come across any question later, you can reach out to KSTA. I'll try to answer that through KSTA to you.
You can mention. Yes, sir.
All the organizers for giving this opportunity, and thanks to all the participants, and I wish you all the best.
Thank you, sir. Dr. Bhaskar Guji, sir, any words, sir? Today we have finished all the 4 sessions. Dr. Bhaskar, sir.
Okay, I think all these sessions are quite useful. I think some are practical in nature also. So good. Thank you, sir. Cyber security is one of the key area I heard now. Thank you very much, sir. Thank you. You can close now. Okay.
Thank you, sir. Thank you, sir. So we will end the sessions today. Tomorrow, I request all of you to join by 10:30 to 10:45. By 11, the session will be going to start. So tomorrow there will be 4 sessions. Hope all of you have received all the links and the schedule also. And
Thank you all.
going to share a feedback link. Please submit the feedback form before 5 o'clock. So it will be closed after that. Thank you. Thank you very much, sir.
Thank you.
On behalf of KSTA and on behalf of all the managed team, Assistant Director Dr. G. Bhaskar sir and his team, and Dr. Chandrakant Lingdal and other technical team and non-technical team of KSTA and managed, and all the participants. Thank you very much, sir. Udashankar Puranik sir, thank you
Thank
for
you.
the
Thank you.
presentation. If any questions related to the topic, you can ask or mention in the WhatsApp group also, or you can contact us offline also. Thank you. Thank you very much once again.
Thank you very much.
Now I am going to drop a feedback link. So before 5 o'clock, I request all of you to submit it. Thank you. Bhaskar sir, thank you, sir. See you tomorrow, sir.